What's up, guys? We made it week 10. We are going to go over factor analysis today. Super straightforward. I'm pretty much going to do this whole exercise, most of this exercise for you. Um, so just follow along, but towards the end, you're going to be interpreting these factors. So don't think that you can just look at the video and copy and paste the answers, because you will have to do a little bit of work, but let's get into it. So I imported my spreadsheet already into JAMOVI, and this worksheet is going to ask you a few simple questions. So you have all of these items, right? And this data over here was filled out by people. So people rated these items, right? And now we're going to do a factor analysis to see like how these items line up under certain factors. Like, do they represent a factor being like a variable? Like, does it represent job satisfaction? Does it represent, what does it represent? So first, we're going to see how many factors to extract and why. And that's going to be based off of these eigenvalues and proportion variance and scree plot. And then we're going to interpret all of this stuff. So let's get into it. So we have this data set. I've imported it already. We're going to go to factor. We're going to go to principal component analysis. And then just throw all of these items in there. And then we're going to go to the method. We don't want to rotate this because we want to see how many factors to retain. We're going to do it based off of an eigenvalue. Again, because we want the rotated, unrotated values, and we're looking for anything greater than 1. So let's do the component summary, initial eigenvalues, and discrete plots. Double check that I did this correctly. Yep. Okay. So we can see there's this jumbled mess of things, right? These questions are mapping onto these 3 factors. But we can see here from the component analysis that there are 3 components that we want to retain based on eigenvalues. So if you look over here, this eigenvalues table, you can see this eigenvalue 6.869, 3.7, 1.8. These are all greater than 1. So these are the ones that we want to retain, these first 3 components. And that's why there are 3 components here. So we can look and see that these components, each component is responsible for a certain percentage of variance in these questions. So 36.15% of the variance is coming from component 1, and so on and so forth. And we can also look at this scree plot here and see that like this line, if this line is 1, there are 3 factors that are greater than 1. So I've already copied and pasted this stuff into my worksheet. And the first question is going to be how many factors you extracted and why. So we extracted 3 factors, 1, 2, 3, because they had eigenvalues greater than 1. Super straightforward. So now that we know that we're going to extract 3 factors, let's go and rotate these eigenvalues so that we can interpret them. So I'm just going to do a new analysis so you guys can see it from the start, because it's going to be a little bit different. So before we had none, but now we're going to keep it on Varimax rotation. So we're going to rotate it. And then this time keep it on parallel analysis. And then you're going to do the same thing, do a component summary. Well, let's just do component summary because we know that, and initial eigenvalues. Actually, let's just do the scree plot too. Okay, so now that we've rotated it, we can see that this table looks a little bit different than the table before. So we can see that these questions are mapping onto certain components or factors. And the factors could also be thought of as variables, so like self-efficacy or job satisfaction. Excuse me. So just use your imagination. This will all make sense in a second here, but I just wanted to illustrate that we are looking, like some of these items are going to map onto multiple factors. And you can see this HE3 maps onto component 2 and 3. We're going to want to use the eigenvalue from component 3 because it's greater than this, right? So let's go through these and see, because we're going to end up filtering some of these values out just to make it easier to read. So this doesn't look like it's computing anything. So it's like we need something that's 0.4. So I would do 0.6. So hide all the loadings below 0.6. And see, look at that. That's actually a lot better. So you can see that these three components, 1, 2, 3, 1, and then so on and so forth, map under these, or these items map under these components, right? And we still have the first three factors retained, so nothing has changed. We've just unrotated these values. So let's go back to the worksheet. So we did a principal components analysis. This is the second set of tables. You don't really need this, but just to show like what rotation does for the variance and why we retained the factors before we rotated. I thought it was good to show this table as well. So we know that we've retained all the eigenvalues greater than 1, three factors that are greater than 1. And then we did a principal components analysis with these 19 items. And the initial eigenvalues showed that the first three factors could be retained because they explain 36, 20, and 10% of the variance, respectively. And remember, we got this from the component statistics table. So clearly factor 1 is like something's going on there. That must be something super important. And then we did this Varimax rotation, and then we retained all of the items that were the factor loadings that were over 0.6. So we literally just filtered them out. And then we were left with this table. So now you're gonna go to either, I think you should have this table. If not, you need to make your own table. This is like an APA formatted table with a component analysis, principal component analysis, and you can see that it's just quite literally like I transposed these values from the second analysis over to this table. So your job is to answer this question. Can you interpret and define the factors, report the factor loadings with Varimax rotation, so these values right here from the second analysis, and interpret them? I think that's repeated twice. So name and define each interpersonal harmony factor, and remember the factor is not these questions. This is the factor as the component. So what is it about DA1, if a DA1, DA2, and so on up until DA9 that represents one factor? Like what could this factor be? So use your best judgment, use these questions in your explanations, and that's pretty much it. Let me know if you have any questions, but I will see you in lab tonight.